Okay, so hi there everyone. We're going to continue with our batch of videos in the grade 11 statistics and probability lessons or playlist or course. What we're going to do here is we're going to answer the permutation and combinations exercises that was presented two videos before. It is composed of three items. Actually, there are three more items to go. And let's take it one step at a time, and we're going to answer this first. Okay, so let's answer this. There are three of them here, and we're going to continue down below, and let's answer them um, one by one. So from number one, from 8 persons, how many committees of 3 members may be chosen? Okay, so again, from 8 persons, how many committees of 3 members may be chosen? So what we're looking here is that we're only choosing committee members. We're not actually getting them in order. There's no rank, there's no officers here. We are only creating committees composed of 3 members. So this is clearly a combination problem because we're only choosing and selecting. We're not arranging them in order. And there's no sense if we're going to arrange the members of the committee, okay, which is composed of 3 members each. So from 8 persons, which we will consider our n, so we will call n as 8 and our r to be 3, which is there are 3 persons. Okay, now what we're going to do is we're going to choose 3 from 8. So we have 8 choose 3. Okay, now we're going to use the formula if you don't have the calculator, so it's better. Rather, it's okay. Okay, I mean it's better to have the calculator, of course, but let's have it. Let's try it without a calculator. So n 8 choose 3, so that's going to be 8 factorial all over 3 factorial here times 8 minus 3 factorial. Okay, so 8 minus 3 is 5 factorial. So what we're going to do is 8 factorial all over 3 factorial times 5 factorial. Okay, now let's extend 8 factorial as we know it. So using the definition of a factorial, so we have 8 times 7 times 6 times 5 factorial. Why did we stop at 5, sir? Because we can cancel the 5 factorial here to that 5 factorial above. So we will cancel it there. And then we know 3 factorial is 3 times 2 times 1. We will cancel 3 times 2 to cancel the 6 here. So we are left with 8 times 7. 8 times 7 is clearly 56. Okay, so meaning there are 56 ways to create, or there are 56 committees composed of 3 members, which we will choose from these 8 persons here. Okay, so there are 56 ways, okay, for them to be chosen. Okay, so that's it for number one. For number two, what we're going to do is we're going to compute these actually values, making, just practicing our calculators stuff. Actually, you can answer the one above here. You can just write on your calculators 8 NCR 3. That will give us 56. Okay, let's go to number two now. Well, you can answer them with your calculators, but well, the direction says to compute. So let's try to practice our computations. So what we're gonna do, since this is a p, so that's permutation, this can be written as, 6 factorial all over 6 minus 4 factorial. Sorry, 6 minus 4 factorial. Quantity factorial, of course. So what we have is 6 factorial. 6 minus 4 is 2 factorial. So we need to extend that. What we'll have is 6 times 5 times 4 times 3 times 2 all over 2 factorial. So that's just 2. We're going to cancel it like that. And then what we want to do is to multiply all the remaining numbers. So 6 times 5 is 30. 30 times 4 is 120. 120 times 3 is 360. So that's our answer for number one. Okay, for number two, 5p5. So by the definition of a factorial, when you have n pn, so this is just the n, right? This is n, this is r in this scenario. Here, this is r all n. So imagine if we're going to write it in this manner using the formula still. So what we have is 5 factorial all over, 5 minus 5 factorial, quantity factorial. So that gives us 0 factorial. So 0 factorial is 1, which leaves us only 5 factorial. That's the reason why, remember our formula that npn is simply equal to n factorial, because that's the reason. The denominator makes it like this. So 5 factorial is, 5 times 4 times 3 times 2 times 1. 5 times 4, let me write it down so that we can compute mentally. 2. We don't need to write 1, right? 5 times 4 is 20, 20 times 3 is 60, 60 times 2 is 120, so that you can see. So that's our answer for number 2. Number 1, number 2. Let's proceed to number 3. Since this is C, that is combination, so what we want is 9 factorial all over 2 factorial. We have another formula here, right? Compared to the permutations formula. So 2 factorial times quantity of 9 minus 2 factorial. So let's extend, let's fix the denominator. What we have is 9 factorial all over 2 factorial. 9 minus 2 is, 7 factorial. So let's write it there. Let's extend now the 9 up until 7 factorial only. What we have is 9 times 8 times 7 factorial. Why? Because we're going to cancel that with the 7 factorial below. So what we have is we're going to cancel this and this. We're left with 9 times 8 divided by 2. So we're going to cancel 2 by the 8 here, which becomes 4. 9 times 4 is 36. So that's our answer for letter C. And actually, we have another one here down below. Let's just answer this. This is letter D, 7p3. So this is permutation. What we have is 7 factorial all over 7 minus 3 factorial, quantity factorial. Um, this will give us, 7 minus 3 is 4 factorial. So 4 factorial above is 7 factorial. Let's extend this by the definition of factorials. So what we have is 7 times 6 times 5 times 4. Let's end there because we will cancel that with the 1 below. Cancel this. And then let's compute this. 7 times 6 times 5. Maybe we can start with 6 times 5 is 30. 30 times 7 is 210. And that's our answer for letter D. Okay, so we're done with number 2. Actually, you can check all of the solutions make in a calculator. Try to check if it works. So 6p4, let me do that likewise. So in a calculator, 6 p4 is indeed 360. That's correct. 5p5 is that's trivial. That's 120. 9 ncr2 is 36. That's correct. And for letter D, 7 NPR 7 NPR3 is indeed 210. So that's correct. Let's go to number 3 now. This is our last part of this video. Let's answer this. How many, or rather, in how many ways are there to select the starting 5 from a basketball team from a pool of 15 men who can play all of the positions equally? So we want to choose 5. Okay, so we're not ranking them. Okay, we're just choosing or selecting. Take note of the word select. 5 men or 5 basketball players from the 15, all equally skilled players. So what we're going to do is this is a combination problem since we're only choosing. So what we have is this is our n, this is our r. So we have our n to be 15 and our r to be 5. Okay, now we will have it like 15 choose 5, all right? We're making use of the formula if you want to use the formula. If you have the calculator, so that's good actually. So what we have is 5 factorial here, all over 15 minus 5 quantity factorial. Okay, now um, let's do the math in the denominator, leaving us with in the numerator 15 factorial still. We have 5 factorial here and then times 10 factorial. And then we will extend this. 15 minus 5 is 10, right? So we'll extend this 15 times 14. We're going to extend it only until 10 factorial because we will cancel that up. 13, 12, 11 times 10 factorial. We will cancel it with the 10 factorial below so that we can get rid of the 10 factorial. Okay, and then we have 5 factorial here. We're going to extend that 5 times 4 times 3 times 2 times 1. We don't need to write times 1. Well, we can see that 5 times 3 is 15. We can cancel this up. 4 times 2 is 8. We can cancel 4 and 12. This becomes 3. And then 2 is going to be canceled with 14. That's going to give us 7. So we are left with what? 7 times 13 times 3 times 11. Well, this is quite familiar. Okay, I think we have had this already. So this becomes, if we're going to manually have this, so this becomes 91, okay, times 33. So 91 times 33, what is that? What we have is what? 27. Okay, 91. You know Vedic maths. I want to teach you that. So 9 times 3 is 27. 9 times 3, we'll use the sutra vertically and crosswise. 9 times 7, 9 times 3 is still 27 plus 3, which is 30. So what we're going to have is something like this. And then 3 times 1 is 3. So do the carries. What we have is 27 plus 3 is 30. So what we have is 3003. So there are 3003 ways to do that. Okay, if you want to explore more of Vedic mathematics, I have a full playlist about that. You may want to check my channel for that. You can see that very easily in the homepage of my channel. So that's it for for this video. We have done the 3 exercises, and hopefully you have learned something from this. And yeah, that's it. Hope you like and subscribe, and see you in the future videos. Thank you very much.